Imagine standing under a clear night sky, gazing up at the vast expanse of stars that have captivated humanity for millennia. Each twinkling light tells a story of cosmic drama, births, lives, and explosive deaths that shape the universe itself. Among these celestial giants is Betelgeuse, a fiery red supergiant in the constellation Orion, visible to the naked eye and a constant reminder of the universe's impermanence. While stars may seem eternal, they are anything but. On astronomical timescales, Betelgeuse could explode in a supernova at any moment, though any moment might mean waiting another 100,000 years. This isn't hyperbole, it's the thrilling reality of stellar evolution, where patience is measured in epochs, and the payoff is a spectacle that could light up our skies like nothing we've seen in recorded history. Join me as we unravel the science behind this cosmic drama, explore breathtaking images from the cosmos, delve into the enigmas of black holes, and anticipate a rare stellar explosion that might illuminate our skies in our lifetime. By the end, you'll not only understand these wonders, but feel compelled to step outside and scan the heavens, wondering what secrets they hold. Stars like Betelgeuse begin their lives in vast clouds of gas and dust, collapsing under gravity until the core's pressure and heat ignite nuclear fusion. This process fuses hydrogen into helium, releasing tremendous energy that counterbalances gravity's inward pull, keeping the star stable during its main sequence phase, its adulthood. Our Sun, a middle-aged star at 4.6 billion years, is in this phase, steadily powering life on Earth. But Betelgeuse, with a mass 15 to 20 times that of the Sun, burns hotter and faster, racing through its main sequence in just a few million years. As its hydrogen fuel depletes, the core contracts, heating enough to fuse helium into carbon, then carbon into oxygen, neon, and silicon in successive layers, like an onion building shells. Each fusion stage causes the star's outer layers to expand, transforming it into a red supergiant. Betelgeuse is so vast that, if placed in our solar system, its surface would engulf Jupiter's orbit. Its ruddy hue comes from cooler outer layers, glowing at lower temperatures than the intense blue-white of hotter stars. The drama escalates when fusion reaches iron. Unlike lighter elements, fusing iron absorbs energy, halting the outward pressure that resists gravity. In a fraction of a second, the core collapses, triggering a supernova explosion, one of the universe's most energetic events. This blast scatters the star's material, seeding space with heavy elements like carbon and iron, essential for planets and life. Betelgeuse is in this late red supergiant phase, likely fusing silicon into iron. Observations show it pulsating, varying in brightness every 400 days, a sign of instability. In 2009, it contracted by 15%, sparking speculation. Then, from late 2019 to early 2020, Betelgeuse experienced the Great Dimming, fading to two-thirds its normal brightness, the dimmest in over a century. The universe is a gallery of cosmic wonders, and the Hubble Space Telescope has captured some of its most breathtaking masterpieces. Among these is the spire in the Eagle Nebula, a towering structure of cold gas and dust, stretching 9.5 light-years high. This stellar nursery is sculpted by ultraviolet light from nearby hot young stars, boiling off hydrogen gas and creating a hazy glow. Dense, dark regions resist erosion, while bright, heated gas may trigger new star formation under pressure. Within the spire, dense pockets collapse under gravity, forming stars the size of our solar system. The interplay of ultraviolet light with oxygen, blue, and hydrogen, red, paints a vivid backdrop, showcasing the dynamic processes of starbirth. Traveling 210,000 light-years to the small Magellanic Cloud, we encounter NGC 346, a vibrant star-forming region. At its heart lies a brilliant cluster of stars, surrounded by jagged arches of cool, dark gas. Ultraviolet light from these stars erodes the gas, leaving wind trails behind denser globules. This cluster hosts the brightest star in the small Magellanic Cloud, a beacon of intense activity. Similarly, the Crab Nebula, the remnant of a supernova observed in 1054 by Chinese and Japanese astronomers, reveals a bluish glow powered by a neutron star at its center. This 30-kilometer-wide remnant, spinning 30 times per second, emits X-ray beams, illuminating the surrounding hydrogen gas. The Orion Nebula, a favorite for its vivid colors, houses 3,000 stars, including the trapezium, a quartet of massive stars shaping the nebula with stellar winds. Brown dwarfs, or failed stars, dot the scene, unable to sustain fusion like our Sun. The Pinwheel Galaxy M101, a grand spiral 21 million light-years away, showcases distinct arms teeming with star-forming regions, driven by supernovae and black holes. The Cigar Galaxy M82, a starburst galaxy, births stars 10 times faster than the Milky Way, fueled by tidal interactions with its neighbor, M81. Its brightest X-ray pulsar, M82X2, defies expectations with its intense radiation. Cassiopeia A, the youngest supernova remnant in our galaxy at 11,000 light-years, glows with a 30 million degree shell expanding at 6,000 kilometers per second. The Lobster Nebula, home to the massive Pismus 24-star cluster, and NGC 602, with its clear view of background galaxies, further illustrate the universe's diversity. Finally, NGC 1672, a barred spiral galaxy 60 million light-years away, dazzles with starburst activity around its central bar, its arms stretching into the cosmic void. In 2025, a rare celestial event will captivate skywatchers. The Blaze Star, or T Coronae Borealis, a binary system 3,000 light-years away in the Northern Crown constellation, will erupt in a nova. Unlike a supernova, which destroys a star, this nova results from a white dwarf siphoning hydrogen from its red giant companion. Over decades, this material builds up, igniting a thermonuclear explosion every 80 years, boosting the system's brightness 1,500 times to a magnitude of 2, rivaling Polaris. Last seen in 1946, the nova is predicted for mid-2025, visible to the naked eye for days. First recorded in 1866 by John Birmingham, this event offers a chance to witness cosmic fireworks without a telescope. Located between Hercules and Buddhas, just below the Northern Crown's arc. Throughout history, stellar events like novae and supernovae have shaped human culture and imagination, inspiring myths, art, and scientific inquiry. Ancient Chinese astronomers in 185 AD recorded a guest star, SN 185, visible for 8 months, now confirmed as a supernova remnant. In 1604, Johannes Kepler's supernova dazzled daytime skies, influencing early modern astronomy. These events, rare and awe-inspiring, reminded humanity of the universe's grandeur and unpredictability. Today, the anticipated Blaze Star Nova connects us to this legacy, inviting everyone to look up and ponder our place in the cosmos. Observatories and citizen scientists will collect data, refining our models of binary star systems and stellar evolution, while the public marvels at a spectacle that transcends generations. As we anticipate Betelgeuse's supernova and the Blaze Star's nova, cutting-edge technology promises deeper cosmic insights. The James Webb Space Telescope, operational since 2021, peers through dust with infrared imaging, revealing hidden star-forming regions and black hole accretion disks. The Vera C. Rubin Observatory, scanning the sky since 2025, detects transient events like novae in real time. Amateur astronomers, armed with affordable telescopes and apps, share discoveries instantly on platforms like X, democratizing science. These tools bridge professional research and public wonder, ensuring that when Betelgeuse or the Blaze Star ignites, we'll all share in the awe, connected by our curiosity about the cosmos. The mechanics of stellar explosions, whether supernovae or novae, are a testament to the universe's raw power and complexity. Supernovae occur when massive stars, like Betelgeuse, reach their end. The core's collapse releases a shockwave, expelling outer layers at speeds up to 30,000 kilometers per second, creating elements heavier than iron, like gold and uranium. This energy, equivalent to billions of nuclear bombs, briefly outshines entire galaxies. Novae, like the blaze stars, are less destructive but equally fascinating. The white dwarf's accumulated hydrogen ignites in a surface explosion, not destroying the star, but ejecting material in a brilliant flash. These events, governed by nuclear physics and gravity, highlight the delicate balance of forces that shape stellar life cycles. Studying them refines our models of nucleosynthesis, explaining how the universe forges the elements that compose everything from planets to people. The rise of citizen science has transformed astronomy, turning enthusiasts into active contributors to cosmic discovery. Platforms like Zooniverse allow volunteers to classify galaxies or identify transients in telescope data, aiding projects like the Vera C. Rubin Observatory's surveys. For the blaze star nova, amateurs worldwide will track its brightness, sharing real-time data via apps like Sky Safari or posts on X. Historical novae, like the 1866 blaze star discovery by John Birmingham, show how non-professionals have long driven progress. Today's technology amplifies this impact, with affordable telescopes and spectroscopy kits enabling backyard astronomers to contribute to peer-reviewed studies. This global collaboration not only accelerates research, but also fosters a shared sense of wonder, making events like the 2025 NOVA a collective human experience. Stellar phenomena challenge our perception of time, reminding us of the universe's vast timescales. Betelgeuse's supernova, imminent in cosmic terms, may not occur for millennia, yet its light will reach us from 640 light-years away, a snapshot of events centuries past. The blaze star's 80-year nova cycle feels rapid compared to supernovae, but its predictability underscores the slow, rhythmic pulse of stellar evolution. These events contrast with human lifespans, urging us to embrace patience and perspective. When the blaze star erupts, its brief visibility, days or a week, will feel fleeting, yet it connects us to processes spanning billions of years. This cosmic perspective humbles us, inviting reflection on our place in an ever-evolving universe and inspiring us to cherish each celestial moment. The universe is a vast, interconnected web where every star, nebula, and black hole plays a role in a grand cosmic narrative. The elements forged in Betelgeuse's core will one day scatter across space, potentially forming new stars, planets, and even life, just as ancient supernovae seeded Earth with the carbon and oxygen in our bodies. The blaze star's nova, while a localized event, reflects the intricate dance of binary systems, where gravitational interplay drives explosive outbursts that enrich the interstellar medium. Black holes, with their space-time warping gravity, anchor galaxies, influencing star formation across millions of light-years. Hubble's images, from the Spire's star nurseries to the Pinwheel Galaxy's spiral arms, reveal this interconnectedness, showing how each cosmic event ripples through the universe. As we observe these phenomena, we're not just spectators, but participants in a story that began billions of years ago, urging us to look up and feel our connection to the cosmos. As we await Betelgeuse's supernova and the blaze star's nova, advances in technology promise deeper insights into these phenomena. The James Webb Space Telescope, launched in 2021, complements Hubble with infrared observations, peering through dust to reveal hidden, star-forming regions and black hole accretion disks. Ground-based observatories like the Vera C. Rubin Observatory, operational since 2025, scan the sky for transient events, potentially catching the blaze star's eruption in real time. Amateur astronomers, equipped with affordable telescopes and apps, democratize discovery, sharing observations instantly via platforms like X. These tools bridge the gap between professional science and public wonder, ensuring that when Betelgeuse or the blaze star lights up, we'll all be watching. The universe is not just a distant spectacle, it's a call to curiosity, urging us to explore, question, and connect with the cosmos. Whether it's Betelgeuse's looming supernova, the blaze star's fleeting nova, or the eerie pull of a black hole, these phenomena remind us that our world is part of a larger, ever-changing tapestry. Step outside on a clear night, find Orion's red beacon or the Northern Crown's subtle arc, and let the sky ignite your imagination. Share your thoughts, plan your stargazing, and join a global community watching the heavens. The next cosmic event is closer than you think. Don't miss it.